Good morning, students. We'll start the today's class. In the today's class, we are going to discuss about latches and flip-flops. So far, in this chapter, we have discussed about combinational circuits. Right now, we are going to discuss about the sequential circuit. So before we start about the latches and flip-flops, so you should clearly know the difference between a combinational circuit and the sequential circuits. So what is the objective of this part? So in this part, we are going to discuss about the operation of the basic latches like SR and D latch. Then we'll be explaining the operation of the four types of flip-flop: D flip-flop, SR flip-flop, JK flip-flop, T flip-flop. Then we will be deriving the characteristic equation for the flip-flops, then timing diagram of the different flip-flops and the latches, and at the end we'll be discussing about the master-slave arrangement of the flip-flops. So before we discuss about the latches and flip-flops, as I said, you should know the difference between a sequential circuit and the combinational circuit. So can anybody tell me what do you mean by a combinational circuit? What is combinational circuit? And then we'll see what is sequential circuit and the difference between the combinational and the sequential circuit. And once we know the difference between combinational and sequential circuit, then we can discuss about the different types of latches and the flip-flops. That's what we have to discuss in this part of this particular module 4. Yeah. Anyone can give me the definition of what? Combinational circuit.
Sir, in combinational, the output depends on present input, only present input,
Okay.
whereas in sequential, it also depends on past input.
Okay. Yes, any other difference? Can you define what is combinational circuit, sequential circuit? Examples of combinational circuit, sequential circuit? Yes, Isha? What is combinational circuit, and can you give me few examples of the combinational circuit? Yes.
Sir. In combinational circuits, the output depends only on present inputs.
Okay.
And in sequential circuit, output depends on present input and also past output. And in combinational logic circuit, there is no feedback.
Okay. Very good.
And in sequential, there is a feedback.
Yes.
And example for combinational circuit is multiplexer, decoder.
Yes, very good.
And in logical circuit, flip-flops and
Flip-flops, okay, counters, registers are the examples of the sequential circuit. That's what I told. So far we have studied about the combinational circuit. We have discussed about half adder, full adder, half subtractor, full subtractor, multiplexer, parallel adder, right? Decoder, encoder, all these PL implementation we did. All those we call it as the combinational logic circuit, wherein output at any given time entirely depends on the present inputs. That means combinational circuit doesn't have to remember anything. What is the input at a particular time? Based on those inputs given, it will give you the specified output. Such circuits are called as combinational logic circuit. On the other hand, we have sequential logic circuits, wherein output not only depends upon the present inputs but also depends upon the past outputs. That means the circuit has to remember the past history of the circuit, because output is not only dependent on the present input but it also depends on the past outputs. Hence, such circuits should compulsory have something to remember the past outputs. So definitely there has to be a memory element, or there has to be a feedback mechanism to remember what was the previous output. Hence, in simple words, we can say that a combinational logic circuit with feedback, or a combinational logic circuit along with memory element as a feedback, is called as sequential logic circuit. And the examples for the sequential logic circuits are the basic building block is a latch or a flip-flop, and the other example for the sequential logic circuits are a register, that is REGISTER, register, counter, right? All these are the examples, shift registers, right? Universal register, all these are the examples of the sequential logic circuit where output not only depends on the present input but also on the past output, right? So as I already told, sequential circuits have the property that output depends not only on the present input but also on the past sequence of inputs as well as the output. That means sequential circuit has to remember about the past history of the inputs in order to produce the present output. And latches and flip-flops are the commonly used memory devices in sequential circuit. A memory element that has no clock input, normally we call it as a latch, and a memory element with a clock, we call it as a flip-flop. So that is the major or basic difference between a latch and a flip-flop. Both are a single bit memory devices. If the memory element is having a clock, we can call it as a flip-flop, and a flip-flop without a clock is called as a latch. So the switching circuits that we have studied so far have no feedback. So all those circuits which you have studied like multiplexer, demultiplexer, decoder, encoder comes under the category of combinational logic circuit. Right? So in this circuit, if you give the feedback, then we get what is called as the sequential circuit. So in combinational logic, there is no capability to hold the value of the input. All these combinational circuit, they don't have a property or provision to retain the value. The value changes immediately when the input changes. They will not store the value. There is no storage capability in the combinational logic circuit. Whereas on the other side, when we talk about the sequential logic circuit, definitely they can store the information into it. And that's why the sequential logic circuit has the memory element or the feedback. So the basic structure of the sequential circuit is shown here. You can see there the combinational logic circuit, if you add storage elements to it, and then this particular arrangement wherein we have a combinational circuit, storage element and feedback is called as sequential logic circuit. And normally when we have a clock, the circuit becomes synchronous because all the operation will be happening with respect to clock. That's why the circuit is called as synchronous. So obviously in sequential logic circuit, clock plays a very important role. Then can anybody tell me what do you mean by clock in sequential circuits, or how do you define a clock? Yes? How do you define a clock? Can anybody tell me how we can define a clock? Because as I said, clock plays a major role in the sequential logic circuit. So the circuit becomes synchronous when we apply the clock or when we apply the common clock, right? So how do we define a clock in sequential circuits? Yes?
So symmetric square wave used to change the state of sequential circuits.
Okay, not necessarily always symmetrical. Many a time we use symmetrical only because the on time and off time should be same. Or we can say that a periodic square wave, instead of calling a symmetrical, we can call a periodic square wave can be used to change the state of the sequential circuit. Such periodic square wave is called as a clock. And when I say periodic square wave, it will have two different edges. When I say periodic square wave like this, you can see here, this is of course, as you said, it is a symmetric, right? Or here on time is equal to on time. So if you have a periodic square wave, such periodic square wave can be used to change the state of the sequential circuit. We call it as a clock. And clock can be generated by using the inverter, by connecting feedback directly to the inverter. We can generate such type of clock. So we can consider this type, this is one type of oscillator. You know that what is oscillator? Oscillator is one which oscillates or which generates oscillation of desired frequency, right? So if you generate the oscillation which are square wave in nature, then that is used as a clock. And when you see this clock, here, you can see there are two edges. One edge is changing from 0 to 1, another edge is changing from 1 to 0. So the edge which change from 0 to 1 is called as what? Can anybody tell me? There are two edges. One edge is changing from 0 to 1. So this is that edge which is changing from 0 to 1. And there is another edge that is changing from what? 1 to 0. That means every clock, now this is called as one clock cycle from here to here. This is the time period of the clock. So you can see here, there are two edges in every clock cycle. One is changing from 0 to 1, another is changing from 1 to 0. The edge which is changing from 0 to 1 is called as what? A rising edge or the leading edge of the clock or positive edge of the clock. Similarly, the edge wherein it is changing from 1 to 0 is called as what? Negative edge, trailing edge or falling edge of the clock. So this edge is called as leading edge, positive edge or a rising edge of the clock, whereas this edge is called as trailing edge, negative edge or falling edge of the clock. So you can make your circuit sensitive either to leading edge or the falling edge of the clock. That's why normally all sequential circuits or flip-flops are edge triggered rather than level triggered. So if you use a latches are normally level triggered. That means when the clock is either 0 or 1, or when the input is 0 or 1, the outputs will be changed. But in case of sequential circuit, most of the sequential circuit are edge triggered, that is either positive edge triggered or the negative edge triggered. So whenever the rising edge or a falling edge occurs, only that instance the output will be changed or the states will be changed. So such circuits are called as edge triggered circuits, and almost all the circuits, sequential circuits, are edge triggered. So this type of a square wave is called as a clock. I hope it is clear. Like these are the different ways in which we can generate that clock. So if it is, suppose if we have given input as 0 to the inverter, its output become 1, and if that 1 is given as another inverter, it becomes 0. Or we can have this feedback loop, simple loop of two inverters, right? And you can get the feedback signal, and it can be used in the sequential logic circuit. So this is one example. I want all of you can just try this as a homework, because already we have discussed about the timing diagram, gate delays and all. You can just have a look at this question. Assume that the inverter in the given circuit has a propagation delay of 5 nanoseconds and the AND gate has a propagation delay of 10 nanoseconds. So you have to draw a timing diagram for the circuit showing the signals X, Y and Z. Assume that initially X is 0. So obviously when X is 0, assume that initially X is 0 and Y is 1. After 10 nanoseconds, X becomes 1. For 80 nanosecond, X remains 1, and then X will go to 0. For this case, you have to draw the timing diagram, right? So what they have given is, at initially they have given X is 0. Like you can have X here, which is 0, and Y is 1. X is 0, whereas Y is 1 like this. And then after 10 nanosecond, say here, I'll consider this is 10 nanosecond, X will become 1 and it remains high for 80 nanoseconds. You consider that it is on for 80 nanosecond and your Y remains high throughout. For this case, you have to draw the timing diagram for Z, and you have to assume that this gate has a propagation delay of 5 nanosecond and this gate has a propagation delay of 10 nanosecond. So at this particular instant, you have to check what is X and what is Y, right? So here x is 0, y is 1. X is 0, y is 1. But initially they have given z. Yeah, initially x is 0, y is 1. So initially I'll assume that here z is 0, right? So here the x has changed now. X has changed to 1, y is already 1. So both the inputs are 1, 1. So till that point, z remains 0. Now, since both are 1, 1, z should become 1. But will the z become 1 immediately here? Will this z become 1 immediately here?
No, sir.
No. Why? Because
There is
AND gate has a propagation delay of how much? 10 nanosecond. That means Z continues to be 0 till 10 nanosecond, then it becomes 1. And now when Z becomes 1, that 1 will come here and the Y will become 0. When Y will become 0? Here after 10 Z has become 1. When Z becomes 1, after 5 nanosecond, Y will go to 0. So by considering this, you have to draw the timing diagram. This you have to do it as a homework. I hope all of you should able to do it. So important thing here is you have to assume the propagation delay of each gate, and when a particular input changes, and when that input changes, what happens to the output of a particular gate, and when the output of the gate changes. By keeping these things in mind, very easily you can draw the timing diagram for this particular circuit, right? Okay, so after discussing brief about, I have not told anything new here. Already whatever you have studied, the same thing I have repeated here. That is difference between combinational and sequential circuit, and little bit about the clock I have told. Now the actual part we have to start with is latch. So we have to study latch, and then that latch can be converted to flip-flop. That's what we have to study. So the simplest of simple latch will be the SR latch, which is also called as set reset latch. So we'll see how this set reset latch can be implemented and how set reset latch works. The basic flip-flop can be improved by replacing the inverters with either NAND and NOR gates. You know that normally we go for NAND gates or NOR gates to implement any latch or a flip-flop. Right. So what is the SR latch? Right. In fact, already you people have studied these latches, flip-flops, everything in your first year engineering. So can anybody tell me what exactly you mean by a SR latch? Yes. And how SR latch can be implemented or constructed? Anybody? Can anybody tell me what is SR latch? Yes, Madhura. What is SR latch and how SR latch can be constructed either by using NOR gates or the NAND gate? Yes? Madhura, are you there?
Yes, sir.
Yeah. Can you tell me what is latch, SR latch, how it can be constructed using what? Either NAND or NOR latch. So basically we will be using a NOR. So can you tell me how SR latch can be constructed using NOR gate? Yes? Yes? Okay, Vishal, are you there? Yes, Vishal. Prashant, you people have already studied. It is just a repetition. In fact, what I am teaching today, I am not going to teach anything new. Whatever you have studied already in your first year engineering, it is just the repetition of that. Yes, Shreya,
Yes, sir.
how we construct a latch, SR latch using NOR gate? Yes. Can anybody? Okay. Simple thing, latch can be constructed by using two cross-coupled NOR gates or two cross-coupled NAND gates. You have to use either two NOR gates or two NAND gates, and the output of one NOR gate should be given as the input to the second, and output of second NOR gate should be given as the input to the first, and the two external input S and R can be given to the two NOR gates one at a time. Like one maybe R can be given to the upper NOR gate and S can be given to the lower NOR gate, right? That is what is simple SR latch is. So the same explanation for the SR latch, and in brief operation of the SR latch will be explained here. You can just listen to this. I hope the screen is visible and voice is clear.
Two NOR gates are connected together in such a way as the output of each
Are you able to listen to the
is one
voice?
of the inputs of the other.
Yes, sir.
This is the SR latch. You can just listen to it.
Results in a form of
Then I'll
positive
explain again.
feedback. SR latches, like all electronic circuits, require power to work. The power connections aren't shown on this diagram. The SR latch has two inputs, R and S, and the output Q. The SR latch also makes the inverse of the output available. On this diagram, you can see not Q, a Q with a bar above it. The starting state here is that S and R are both low. That is, both inputs are 0. Q is high, that is, the output is 1, and not Q, the inverse of this, is 0. Both of the inputs of the top NOR gate are 0, so the output of the top gate is 1. This is exactly what you would expect from a NOR gate. The inputs of the lower NOR gate are 1 and 0, so the output of the lower gate is 0. Because Q is 1, the latch is currently storing 1. Now we apply a pulse to input R to reset the latch. This changes the output of the top gate, and then this is fed back into the lower gate. The lower gate's output also changes, and this is fed back into the top gate. The pulse that was applied to reset the SR latch is then removed, and R is 0 again. But the output at Q is now 0, so the latch is now storing a 0. In order to store a 1 again, a pulse must be applied to input S, which will set the latch. Again, notice how the various changes are propagated around the circuit.
Do you want to start your own business with these three advantages? Number one, you don't.
Sorry.
The set pulse is then removed, and the circuit is now latched into a set state. It's storing a 1 again. Notice that if another set pulse is applied, it has no effect. Applying a set pulse at S will always force
Just all of you
the latch into a
observe
set
how
state,
what happens when the
regardless of
input
the
is
previous
changed,
state of
how
the
the
latch.
outputs are changing or remaining the
Similarly,
same.
applying
I'll
a
explain
reset
it once
pulse
again.
will always force the latch into a reset state. It should be noted that S and R are never left high. That is, neither is ever set continuously to the value 1. The latch is controlled by pulses only. This gives us an unusual looking truth table. When both S and R are set to 0, Q may be 1 or it may be 0, depending on the previous state of the circuit. Let's examine the truth table as this SR latch is reset again. The reset pulse is applied. S is 0, R is 1. Output Q is 0, and its inverse, not Q, is 1. The SR latch is storing a 0. The reset pulse is removed. Both S and R are 0 again. Output Q remains at 0, and its inverse remains at 1. The SR latch is still storing a 0. A set pulse is applied. S is 1 and R is 0. The output Q becomes 1 and its inverse becomes 0. The set pulse is removed. S is 0 and R is 0. Output Q is still 1 and not Q is, of course, 0. Now, the only circumstance we haven't considered is when both inputs, S and R, are set to 1 at the same time. If this were to occur, we'd be telling the SR latch to set the value of Q to both 1 and 0 simultaneously.
You can see the last case is
In
explained
reality,
when both are
Q
1,
would
1.
become
What
0,
happens?
and not Q would also become 0. This would sort itself out if one of the inputs fell to 0 before the other. For example, if R fell to 0 first, with S still at 1, then Q would become 1 again. If, however, both inputs were at 1 and both fell to 0 at the same time, we'd have what's known as a race condition between the two gates. They'd be racing each other to feed back their new output, and it's impossible to know which one would win. Hence, if both inputs are high, the next state of the latch can't be determined. This is not a state that the latch should ever be in. It's illegal. It's invalid. Most of the time, inputs S and R should both be at 0, and only momentarily will one or the other input become 1. And at any time while it's operating, the SR latch should either be in a set state or a reset state, with Q and not Q the opposite of each other. One final piece of terminology. This type of SR latch is said to be an active high SR latch, because the normal condition for S and R is low, and a high pulse at one of these inputs is required to bring about a change. Now let's consider an SR latch built.
That is about the NOR gate SR latch. I don't know how many of you understood. Can anybody try to explain that? Whatever the SR latch you have studied, that's why I just played that simple video, because already you people have studied that. Can anybody will give me the explanation for the same? Yes. What is the SR latch? The same SR latch was explained there. You can see this is the logic diagram for the SR latch, where we have used two NOR gates. One is shown as NOR A, NOR B, and the two inputs are connected as R and S. Right. So the latch will have one or more than one input and two outputs, and the two outputs will be always a complement of each other. So you can see here Q and Q bar will be the two output. This is the block diagram of the SR latch. Two inputs are shown and two output, and the two outputs are complement of each other. And we have not shown any clock here, so that's why it is called as a latch. If you add clock to this, then this latch becomes SR flip-flop, right? So now we have two inputs R and S and the two outputs Q and Q bar, and you have to explain the operation of this circuit. Before we explain the operation of this circuit, what is the important property of the NOR gate? If you recall the truth table of the NOR gate, the moment any of the input to the NOR gate is what? If you say the OR gate, in OR gate, one of the input to the OR gate is 1, its output is 1. Only when both the inputs are 0, output will be 0. That is the property of OR gate. Whereas property of NOR gate is what? When both the inputs are 0, only then it will give you output as 1. And if one of the input to the NOR gate is 1, its output will be 0. That is the important property you have to remember. The moment you apply any of the input to the NOR gate as 1, irrespective of the other input, its output will be always what? 0. That is the important property that you have to remember when you are explaining the working of SR latch. Now the first case, whatever is explained there in the video, I am explaining again. When R is 0, S is 0. What happens to the flip-flop? Can anybody tell me? Yes? When R is 0, S is 0. Can you decide the output of the NOR gate when one of the input of the NOR gate is 0? Definitely the answer is no. Because if one of the input to the NOR gate is 1, immediately we can say that its output is 0. But when one of the input to the NOR gate is 0, we will not decide its output unless and until we know the other input also. So for the first input combination, when both are 0, 0, we will not able to predict what is the output. For that, we should know the other input also. Now, what is the other input to the NOR gate A? It is the Q bar output. And the other input to the NOR gate B is the Q output. That means when you apply input 0, 0, you are not able to tell what is the output of this particular circuit unless and until you know what is the previous output of this circuit. So previous output, suppose if I take Q equal to 0 and Q bar will be obviously 1, right? This is the previous state. Like already these values are stored in this latch, and now if I apply 0, 0, definitely now I can tell what is the output. So previously I have considered 0, so this 0 will come to the NOR gate B along with this 0, and what output you are going to get now? Now what will be the output of the NOR gate? Initially with only two R0, S0, we were not able to know what is the output of this. So I have assumed what is the previous state of this latch. Previous state of the latch, if we assume Q equal to 0, Q bar equal to 1. Now what will be the new state when you apply R equal to 0 and S equal to 0? So can anybody tell me what will be the output of the NOR gate B now? Because S is 0, other input to the NOR gate is 0. So both the inputs are 0, 0. So what output you are going to get?
1.
1. Obviously 1. Now this 1 along with this 0, what output the NOR gate A will provide?
0.
0.
That means if I assume previous state of the latch as 0, 1, and now if I apply R equal to 0, S equal to 0, what is the new state I am getting again? This is present state. This is the new state or the next state what we have got. This is the input. When present state is this or previous state is this, and when inputs are this, what is the next state we got? What is the next state we got? 0, 1, which is same as that of what? Previous state. Hence, we can say that when we apply R equal to 0, S equal to 0, state of the latch will not change. Hence, that condition of the latch is called as what? What it is called as? Yes, it is called as no change state of the latch. Then you may ask, what if the previous state what you have assumed is 1, 0? Okay, I'll take that also and we'll check. Right? Instead of 0 and 1, a possibility, because there are two possibilities. Q may be 0, Q bar may be 1, or Q is 1 and Q bar is 0. Now I will take this state. That is Q equal to 1 and Q bar equal to 0. This I will consider as a previous state. Again, I will give the inputs as 0, 0. I'll give R0, ES0. Can anybody tell me now what will be the output? What will be the output for this?
1, 0.
What will be the output now?
1, 0, sir.
Yes. This is not there. This I have removed now. Fine. Now I have assumed this. So what will happen now? Yes. See here, now this 0. This 0 will come here and this will give 0 and 0 will give you output as 1. This 1 will come along with this and it will give you 0. So previously if you assume the outputs as 1, 0, what is the new values we are getting again? What we are getting? The same as that of the previous state. So whether you assume Q equal to 0 or Q equal to 1, you get the same when you apply R equal to 0, S equal to 0. Hence this state of the latch is called as what? No change state. This state of the latch is called as no change state. Okay? Like that. Now can you explain this for the other cases? Right? Now suppose if I take R equal to 0 and S equal to 1, what happens? The second case, if I give this R equal to 0, S equal to 1, what will happen? The moment you give R equal to 0, S equal to 1, the 0 and S is equal to 1 if you give, what happens? The moment R is equal to 0, the output will become 1 now, right? This output become 1 because of, sorry, not R. The moment S is 1, the moment you apply input to the NOR gate as 1, its output becomes 0. So here S is equal to 1 you applied, so this output becomes 0. Then this 0 along with this 0, it will produce the output as 1, irrespective of what is the previous value. Here previous value is not important. The moment you give R equal to 0, S is equal to 1, you are getting Q equal to 1 and Q bar equal to 0. So always you will be getting Q output as 1, and this state of the latch is called as what? What it is called as? Set. Q equal to 1 sets the latch. Is that clear? Now similarly, if you apply the third input, that is R equal to 1 and S equal to 0, what happens now? Yes? If you give R equal to 1, S equal to 0, what happens? Yes, Sejal? R equal to 1, S is equal to 0. Which output, which gate output will be high or low? I have told the moment you see one of the input to the NOR gate is 1, irrespective of other input, its output will be 0. Then this 0 along with this 0 gives you output as 1. That means R equal to 1, S equal to 1 gives me what? Q equal to 0. Always Q will be 0, and this state of the latch is called as what? What it is called as? Reset state. This state is called as reset state. And then the last one, when both are 1 1, what happens? Yes, when you give both the inputs as 1 and 1, R equal to 1, S equal to 1, what happens? The moment you see 1 as the input to the NOR gate, its output will become what? 0. Both the gates will try to give you output as 0, which violates the basic definition of a latch or a flip-flop. What the basic definition of a latch says? What is the basic definition of the latch says? The two outputs of the latch should be always complement of each other. But here when you give both as 1 1, both the outputs are becoming what? Both the outputs are becoming same, which is not accepted. Hence this state of the latch is called as forbidden state. So 1 1 input in SR latch should never be used because it violates the basic definition of the latch. That is what is SR latch is. I hope all of you understood this. Again, I am repeating this, you already studied, it is just a revision of you, and from examination point of view, again it is important. All of you understood this? Yes,
Yes.
or no?
Yes, sir.
That's what each and every step case what I have explained is shown here in different slide. When you give R equal to 1, 0, S equal to 0, then R is equal to 0, S equal to 1, what happens? R equal to 1, S equal to 0, what happens? And lastly, when R equal to 1 and S equal to 1, what happens? And also the timing diagram is shown here by considering a small delay. You can see how the output is drawn. When S is 0, R is 0, no change, Q remains in 0 state, right? Now here S had changed to 1. When S changed to 1, Q should immediately change to 1, but Q had changed to 1 after some time epsilon, that is delta, then it becomes 1. Now here again both are 0 0. When both are 0 0, Q should be what? No change. So what is the previous value of Q here? 1. So it continues in 1. Now R has become 1 here, so Q should become 0 because R equal to 1 resets the latch, S equal to 1 sets the latch. That's why it is called as set reset latch or reset set latch. So the moment R becomes 1, Q should become 0, but Q will become 0 again after some delay called epsilon, that is propagation delay, and then it continues to be 0. So this is the timing diagram for the SR latch for the inputs S and R, right? that simultaneous change in S and R from 1 to 0. That means that when both you give 1 1, it violates the basic definition of the flip-flop. So you should never apply both the inputs 1 to the SR latch. Then this characteristic equation and all, I'll take it up later after discussing all the latches. After discussing all the flip-flops, we will design the we will derive the characteristic equation for the SR latch. So just to summarize what we have studied today, right? I will play you another small video. You can just have a look at it.
मेमोरी एलिमेंट होता है
Of course, it is in Hindi.
स्टोर कर
You can
सकता
just
है वन बिट ऑफ बाइनरी
just a revision what I have
and
studied,
it is
what I have told
used
in
in
this
clocked
class.
sequential circuits और इसे हम clocked sequential circuits में यूज करते हैं। जैसा कि आपने पिछले लेक्चर में देखा था कि मेमोरी एलिमेंट की तरह हम फ्लिप फ्लॉप को यूज करते हैं और ये वन बिट का इंफॉर्मेशन स्टोर कर सकता है, ये आपको याद रखना है। तो फ्लिप फ्लॉप हैज टू आउटपुट, इसके अंदर दो आउटपुट आपको मिलेंगे, या आप ब्लॉक डायग्राम देख सकते हैं फ्लिप फ्लॉप का, तो इसके दो आउटपुट होते हैं। तो कोई भी फ्लिप फ्लॉप आप पढ़ेंगे तो उसके आपको दो आउटपुट मिलेंगे, ठीक है, एक नॉर्मल आउटपुट होगा और एक इन्वर्टेड आउटपुट होगा, ठीक है। और जो नॉर्मल आउटपुट है बेसिकली वही वैल्यू इसके अंदर स्टोर होगी और उसकी इन्वर्ट करके हम ले सकते हैं। तो यहाँ पर आउटपुट है वो नॉर्मल फॉर्म में और कॉम्प्लीमेंटेड फॉर्म में आपको अवेलेबल होता है, लेकिन वैल्यू जो स्टोर होती है वो नॉर्मल वाली ही स्टोर होती है। ऐसा नहीं है कि यहाँ पर दोनों वैल्यू स्टोर रहती है, नॉर्मल वैल्यू ही स्टोर रहती है, ठीक है। तो फ्लिप फ्लॉप कैन मेंटेन अ बाइनरी स्टेट इनडेफिनेटली। तो जो फ्लिप फ्लॉप है वो जो बाइनरी स्टेट इसके अंदर है, जो वैल्यू स्टोर है उसे इनडेफिनेटली रख सकता है जब तक पावर आप सर्किट को डिलीवर कर रहे हैं, या फिर आप कोई इनपुट उसे प्रोवाइड नहीं कर रहे हैं उस स्टेट को स्विच करने के लिए, ठीक है। तो फ्लिप फ्लॉप इज आल्सो नोन एज बाई स्टेबल मल्टीवाइब्रेटर। तो फ्लिप फ्लॉप को बाई स्टेबल मल्टीवाइब्रेटर भी कहा जाता है क्योंकि इसके अंदर दो स्टेबल स्टेट होती हैं, वन हो सकती है या फिर जीरो हो सकती है, ठीक है। Flip-flops are of different types depending on how their inputs and clock pulses cause transition between two states. तो flip flop है वो कैसे प्रोवाइड कर रहे हैं उसके हिसाब से। तो बेसिकली 4 टाइप्स के फ्लिप फ्लॉप्स हैं, SR फ्लिप फ्लॉप, JK फ्लिप फ्लॉप, D फ्लिप फ्लॉप, कोई फ्लिप फ्लॉप आप पढ़ोगे। तो आउटपुट हम बात करेंगे बेसिक फ्लिप फ्लॉप सर्किट और लैच। बेसिक फ्लिप फ्लॉप आप कैसे बना सकते हैं या फिर एक लैच कैसे।
So you can concentrate only on this SR latch using NOR gate, and you people have to do it as a homework. How SR latch can be constructed using NAND
दो
gate.
नॉर गेट की मदद से बेसिक फ्लिप
Both are shown here.
जैसा कि आप
So
देख पा रहे हैं।
similarly, you
लैच
should
को
be able to
करेंगे
study,
सही, तो आप यहाँ पे देख रहे हैं
and you can see what is the change in the circuit arrangement for SR
फीडबैक
latch
कर दिया
using
है, ये
NOR
लैच ऑन
gate
करवा
and
दिया
NAND
एक
gate.
तरीके से, इस वजह से लैच कह रहे हैं, ठीक है। तो यहाँ पर दो इनपुट होंगे, एक को R से रिप्रेजेंट कर दिया है और एक को S से रिप्रेजेंट कर दिया है। R स्टैंड्स रीसेट, S स्टैंड्स सेट, ठीक है। आउटपुट तो दो होने ही होने, Q और QR। यहाँ पर आप देखें S R, ठीक है। तो जब कभी आप नॉर गेट से फ्लिप फ्लॉप बनाओगे तो उस समय जो पहला इनपुट होगा वो R होगा और दूसरा S होगा, इस वजह से इसे RS फ्लिप फ्लॉप कहेंगे। अगर आप NAND गेट से बनाते हैं तो पहला इनपुट S है और
This
दूसरा
is very important difference that you should remember. Like how
दोनों का काम एक जैसा ही होता है,
latches
ठीक
are
है। तो
constructed
अगर
using
आपको
NOR and
RS फ्लिप फ्लॉप आ रहा है या SR आ रहा है तो आप कोई भी बना सकते हैं, ऐसी कोई दिक्कत वाली बात नहीं है, ठीक है ना। लेकिन RS आ रहा है तो मैं कहूंगा आप इसी से बनाएं।
Like you should not call this as RS flip flop and RS latch and these as SR latch. Both are one and the same. But when you are drawing a circuit using NOR gate, first input you have to write R, second you have to write S. And when you are drawing a circuit using NAND gate, first input is S and second is R. So you should not say that this is RS latch and this is SR latch. Both are same. As a thumb rule, like if they ask like SR using NOR, you should write this R and S. So you remember whenever they say latch, SR latch using NOR, so first input should be R, second should be S. And if SR latch using NAND gate, then it should be S and R only. For NOR it is RS and for NAND it is SR. That's what as a thumb rule you can remember, but you should not call them
और
by name.
SR आ रहा है तो ऐसे बनाएं। है बात एक ही, फर्क इसमें कुछ है नहीं, ठीक है ना, क्योंकि हम नॉर और नैंड दोनों से ही बना सकते हैं और इसका ऑपरेशन है वो सेम होगा। अभी यहाँ पे थोड़ा डिफरेंट होगा, लेकिन आगे जब क्लॉक्ड की हम बात करेंगे, क्लॉक्ड फ्लिप फ्लॉप की, क्योंकि अभी तो हम बेसिक की बात कर रहे हैं, क्लॉक्ड में ऑपरेशन एकदम एक जैसा हो जाएगा, ठीक है ना। तो ये बेसिकली लॉजिक डायग्राम्स कहलाते हैं, ये लॉजिक डायग्राम हो गई। तो लॉजिक डायग्राम आप बना सकते हैं। उसके बाद बात आती है ट्रुथ टेबल की। जब कोई सर्किट है, आपको उसका फंक्शन या बिहेवियर बताना है तो उसे हम ट्रुथ टेबल की मदद से बताते हैं, ठीक है। इसके लिए आप ट्रुथ टेबल बना सकते हैं। तो यहाँ पर जब लैच आपको पूछा जाता है तो आप या तो ये सर्किट बनाएंगे या फिर ये बनाएंगे। अगर स्पेशली कह दिया गया है कि नॉर गेट से ही आपको बनाना है तो फिर इसे बनाएंगे, नैंड के लिए कहा गया है तो इसे बनाएंगे, और कुछ नहीं कहा है तो जो आपको अच्छा लग रहा है उसे बनाइए, ठीक है। मैं इसे प्रेफर करूंगा, इसी वजह से मैंने इसे पहले बनाया है, ठीक है। तो अब इसकी ट्रुथ टेबल हमें बनानी है। तो यहाँ पर इनपुट हमारे पास क्या है, आर है और एस है। जब इसकी ट्रुथ टेबल बनाते हैं, इस केस में बना रहे हो चाहे आप इस केस में बना रहे हो, तो कंफ्यूज हो रहे होंगे कि पता नहीं कभी आर ऊपर कर देते हैं कभी नीचे कर देते हैं। अब इसे शुरू से आपको सिस्टमेटिक वे में बताते चल रहा हूँ, जिससे कि आगे आपको कोई कंफ्यूजन नहीं होगा। तो अगर आप, तो ये टेबल हमने बनाया, तो एस पर हमने 1 अप्लाई किया है, ठीक है, और आर पर 0 कर देता, ठीक है। या फिर ये हो सकता था कि दोनों को 0 कर देता, या फिर दोनों। इसका फंक्शन देखने से पहले आपको आइडिया होना चाहिए, जो नॉर गेट होता है उसके,
This is the truth table
नॉर गेट है,
for
इसके अंदर आप
calculating.
देखें कि अगर एक भी इनपुट 1 हो जाता है तो आउटपुट 0 है, क्लियर है। एक भी इनपुट 1 हो गया तो आउटपुट 0 हो जाएगा। जब दोनों इनपुट 0 होंगे तभी आउटपुट 1 होता है, ठीक है ना, ये नॉर गेट में होता है। तो यहाँ पर अगर आप देखें तो ये इनपुट 1 है, तो ये इनपुट 1 हो गया तो हम कह सकते हैं कि दोनों 0 हो गए तो आउटपुट क्या आ जाएगा, 1, ठीक है। तो ये आ गया, क्लियर है। दोबारा समझ लीजिए, हो सकता है कंफ्यूज हो रहा हूँ। एस 1 अप्लाई किया, नॉर गेट के अंदर 1 होगा तो आउटपुट 0 हो जाता है। इसकी वैल्यू क्या है, क्योंकि अगर इसकी वैल्यू 1 हो जाती है तो आउटपुट क्या हो जाएगा, डायरेक्टली डिसाइड कर दिया आउटपुट के 0 हो गया। अब ये 0 यहाँ से, अब हमने दोनों को 0 0 कर दिया, यहाँ पर 0 अप्लाई कर दिया और यहाँ पर 0 अप्लाई कर दिया, दोनों जगह 0 अप्लाई कर दिया। अब जब दोनों जगह 0 अप्लाई कर दिया तो अब आप डायरेक्टली आउटपुट डिसाइड नहीं कर सकते, क्योंकि 0 है इस जगह पर, तो आपको फीडबैक के बारे में पता होना चाहिए कि फीडबैक क्या है, ऐसे इसमें, ठीक है ना। तो ये मान लीजिए कि आपने 1 0 अप्लाई किया है, सर्किट अभी ऑन है, आपने पावर ऑफ नहीं किया है, और अब आप 0 0 अप्लाई कर रहे हैं। इसका मतलब आपको पता है कि पहले आउटपुट जो आया है वो आपका 1 आया है, ठीक है ना। ये पास्ट आउटपुट हो गया कि नहीं, तो ये पास्ट आउटपुट हो गया, तो आप उस 1 को मान लेंगे कि 1 इधर से आया, फीडबैक हो गई, तो इधर ये 1 आ गया और ये 0 था, ठीक है ना। तो 0 और 1 होगा तो आउटपुट क्या आएगा, 0 आएगा, तो आउटपुट आ गया 0, जो पहले था वही। और ये 0 फिर इधर से इधर जाएगा तो इधर क्या कर देगा, 1। इसका मतलब कोई चेंज नहीं हुआ, 1 0 ही आ गया जब आपने 0 0 अप्लाई किया, क्लियर है। तो 0 0 अप्लाई करने पर जो पहले आउटपुट था वही आउटपुट आ रहा है, क्लियर है। अब हमने क्या किया, अब हमने चेंज कर दिया, एस को कर दिया 0 और आर को कर दिया 1।
Like this, all other cases already I have explained to you. This is how we can explain the working of this.
तो आपने ये 1 इधर से जाते हैं वही मेंट अप्लाई किया है, क्लियर है। अगर ये 0 है तो ये हमने नॉर गेट उल्टा हो गया, तो यहाँ पर
this part, the NAND gate part, I want you people to do it as a homework, right? So just try to do this NAND gate part as a homework, and in the next class we'll see the other type of latches, flip-flops, characteristic equation, everything we'll try to study. So again, I am repeating, I have not told anything new today in this class. Whatever you have already studied in your first year engineering, it was just a revision of the same, right? So with this, we'll close today's class. If you have any doubts, you can ask before we close the session for the day. Any doubts, Richa?
No doubts, sir.
Yes. Okay, if there are no doubts, you can leave the class. And the next class, we'll study the further part of this flip-flops and the latches.